So, hello, I'm Julie Lerman. You probably already know that. And I'm talking about using Docker for your databases. So we do, a lot of people already here have experience with Docker, and we use Docker for a lot of the APIs and dependencies that we need in our application so that we don't have to install them all. And people don't realize that you can do the same with databases. There are database engines in Docker. More interestingly to me, I've been a SQL Server person for years and years. So, MySQL's been in, we've had images from MySQL for a long time, and Postgres and some other database engines, but SQL Server also. So what I want to do is I'm going to talk about not just the benefits, but show you demos of how you can integrate databases within your Docker use for dev and test. And also, I'm not going to demo it, but this also leads to CI/CD too. And there are people who are using Docker container for SQL Server even in production. Right, so some of these, you would change some of the patterns of what I'm showing here, though, if you're going to use a production database. So things change, right? I don't even know how many hundreds of years old this wooden bike is. I don't know if you can see it has, or you can try to find the pedal on that bike, right? Bicycles have evolved. That's my bike. It's nice, it weighs 19 pounds, and it has pedals, which is really nice. So, things change. So that's a centuries overview change, but also when we're designing our software, the software is constantly evolving too, especially in the early stages. Once it's in production, still evolving because we have our DevOps patterns and capabilities to just keep our applications evolving after they've been deployed. So we're constantly making those kinds of changes. And with Docker, I'm just looking at the screen. The perspective kind of like, is something missing there? No, it's just that I'm standing at an angle. So with Docker, we've been able to take advantage of sharing source control and sharing these dependencies. Whether it's engines, different engines that we use, or applications that we rely on for making our applications, testing our applications, and deploying our applications. So we've had this capability for quite a while with that, and a lot of times we're just doing unit tests anyway. So you don't need the database as part of that. Right? So when you're deploying it or sharing it, you don't have to worry about the database. But quite often, we still need to do integration tests, right? We need to do some real persistence against the database to make sure things are truly working the way that we expect them to be. I do a lot of domain-driven design. I spend a lot of time working with teams on DDD. And domain-driven design is all about, forget about the database. Right, but even then, you're still going to have to eventually be working with a database, and you need to know how things are working, make sure things are working the way you expect them to do. So adding that in to your process becomes hard because, first of all, especially, so who here uses SQL Server, like a heavy-duty database, right? So installing SQL Server is really fun, right? So you've got everybody on the team has to install SQL Server on their dev machines that they're working on, right? Or, we're going to upgrade to SQL Server 2019. Okay, everybody, time to install that one too. We'll just take the day off so you can do that, right? That's always, a real problem. And then also, as your models are evolving in the application that you're building, then the database schema that you've got to persist that to is also changing at the same time. So not only are we having to deal with everybody kind of doing their own thing with making sure they have a local version of the database server, but also now we have to deal with providing SQL scripts for everybody. And, and then they have to migrate their databases. And a lot of times everybody's kind of doing things their own way, right? They've just got their way of running these things. Or maybe they're using EF Core and using migrations or something like that. So who here is a .NET developer? Oh, okay, so I can really speak to that. I'm actually using Entity Framework, and I'm using half of migration's capabilities in this solution the way I'm doing it. So you'll see that, and that makes it easier for me. I can talk about that perspective of it also. So everything else in the application is like automated. Everybody's got the same process. But then when it comes to dealing with a database or database schemas, everybody's kind of on their own, or has been on their own, or typically still is. So what we want for the database end of this in dev and test, and also in CI/CD, is to have a consistent process that's consistent across the team, that we can automate just the way we're doing with everything else in the application. And with SQL Server, we can even do that with SQL Server. You don't have to say, oh, well, I got to use MySQL now. We're not going to use a real database. I mean, if you're deploying to SQL Server, you want to do your integration tests against SQL Server, not against MySQL or SQLite or something, because there's enough nuances between them. You can really miss something with your tests. So who here is aware that SQL Server does have, first of all, there's a Linux version, and there's an image, actually a number of images. So there you go. Okay, we're done. That's all you need to know. So that's actually kind of a big mind-blowing thing for a lot of people. And it was for me the first time I actually saw this working in Docker, especially the installation part. So we have SQL Server for Linux. That's actually been around since SQL Server 2017. And there's a public Docker image. And for testing, you're probably familiar with licensing. We can use local DB, and we can use SQL Server, Developer Edition, without having to deal with license. So for all of this, for dev and test and all of that, it's not an issue. You can easily use that. So if you want to know more about the Linux edition, it's not like a totally different version of SQL Server. It's just SQL Server, and it runs on Linux. Okay, so you can learn more about that there. And for those of you who are quite familiar with getting things from Docker Hub, so Microsoft moved all of their images to their own Docker repository. So the image information is on Docker Hub, but the actual images that you pull from are mcrmicrosoft.com. So just an FYI on that. And the other thing for anybody who's followed this, they at the same time had created a Windows container image for the regular Windows version of SQL Server. And over the years, they were able to get the size of the Linux image down smaller and smaller and smaller, but Windows containers are a beast. I tried using one once. Well, I used one. It was easy enough on my dev machine, but when I went to deploy it to Azure, it was like, holy smokes. I didn't realize how huge these were. And so they had the Windows container, so you could use it as well if you wanted to. There didn't seem to really be a reason to do that, because if you're running Docker Engine on your computer, you can run the Linux containers anyway, which most people do by default. Anyway, they stopped working on that. They just kind of gave up on it and said some really subtle announcement like a year ago that they just weren't even going to bother with it anymore. So just an FYI on that. But once we've got this image, and once we can create containers with SQL Server running in it, SQL Server becomes just another component in your application, just like anything else you're using, just like the .NET runtime. It's just another component. Even though we've got SQL Server, right? Like this whole thing about installing SQL Server. So if you're using containerized databases, first of all, you can have multiple instances of SQL Server running in separate containers because each one is isolated, right? So there's interesting benefits to there. Maybe you want to test against 2017, you want to test against 2019, or you're working on different applications, right? And so you have a database that you need to set up and work with one application. You can actually have different, it's not just different databases in the same SQL Server. You've got different containers, and each container is running its own instance of SQL Server. I have to be careful not to switch over to my introducing SQL Server for Docker idea and talks, because then we'll be here all day. Anyway, so they are isolated. You can have multiple instances of it. It's mind-blowingly easy to start up a new SQL Server engine because it's already installed. Like the image is there, and you're just running the image. So there's no installation there, like no installation. So for me, that's like a really, really big deal, but really also migrating your schemas and your databases, that's all really important as well. So I'll show you, I'll do this, but I just want you to see that when the Docker run command to get SQL Server started up does have some requirements. So we have the environment variables. You have to literally type, this never changes. It's always except EULA equals Y, because you have to, right? It's such a given. I sometimes wonder why they make you do it. But you always have to put that in, and you also have to identify a password. So the base admin user is always going to be SA for the container. For your databases, you can create your own all your own authentication, authorization, and everything. So you set the password for SA, and then you have to specify the host and the container port. So inside the container, I'm just using default 1433, which is always that. And then the first one, the host ports, and choose your own port, right? Whatever you want. I'm saying 1600. So what that means is on my host computer, when I don't have to do something inside of the container to access it. It will be, my container is going to expose the server through port 1600 so I can access it right on my computer. Does that make sense? It took me a while to wrap my head around that. So hopefully I'm explaining in a way that shortcuts, so you don't have to go through all the what, I don't understand like I did. Another really important aspect of the Docker run command is that you want to run this, depending on what you're doing, but most often you want to run this in detached mode, which means the database becomes interactive. Otherwise, it's self-contained and nothing can access it, right? You can't get to it. So if you want to, spin up the server and then actually do something with it, you want it to be what's called detached. And then finally, you just have to specify which image you want to use, and this one's just going to default to latest, the latest tag, the way I've specified it there. You can also name it, and there's all kinds of other things, but these are the required attributes that you need with a command. If you're planning to use standard, it's one image that serves all the licenses. So it's just a single image, and if then you're kind of by default in developer license, right? Developer SKU. But if you're planning to use it in a scenario, if you're putting into production, you're actually going to use a Docker container for SQL Server in production, then you do have to put your licenses in. And there's some, light requirements on the password, right? So. And I'm just doing demos, so my passwords are usually ones I can memorize. So I'm going to show you a little bit of this in action to begin with. So first of all, I want to point out that, this is Docker Desktop's dashboard, and you can see running containers, which are none right now, existing images, existing volumes, there's none right now. So these images I've already pulled down from the internet, right? Because that takes a little extra time. So usually once you pull it down, then you've got it. If you are trying to create a container based on an image and Docker Engine isn't seeing the image in your local repository, it will pull it down, right? So we're not going to waste time doing that. So I already have the ones that I'm going to need. So here's SQL Server, and that one is the 2019 latest. And I also have 2017 latest, and plain old latest, if you look at the GUIDs, you can see that that's the same as 2017 latest. So these are already on my machine. I'm also going to use something called Flyway as part of this process. So that image is already on my machine as well. But I'm not going to use that quite right away. So the first thing I'll do, and then just again, I have no containers running right now. So it's just dead empty. So I'm going to go to the terminal and yes, I was practicing that before. So I'll just clear and move these lines down a little bit. And I love not having to type all that in. So there's the command, docker run. I've got the environment variables, the required ones, except EULA. I've got my password. I'm exposing this on local port 1620. I'm giving it a name. The container will have the running container will have the name MyDB container, and I'm saying use the latest, use the one that's tagged as latest, which happens to be, in this case, 2017. So who's going to do the timer here? Okay. What that means is the container now exists, but SQL Server still has a little bit of work to do. So here's the container now. And if I click on that, you can see the container comes along with a Docker file and some additional files that have SQL script in them. So the SQL script ran and created, things we know we need in our SQL Server database, like, the model and MSDB, right? All the system databases, and it just set everything up. But still, all of that happened. Let's see, it finished at 14:26:34, and it started at 14:26:31. I have a running SQL Server engine on my computer. Is that freaking amazing? I think the first time I saw that happen, I was like, oh, wait, no, can't, what? Because I've done it enough. So right there, it's worth the cost of entry, which is free so far. And then I'm going to flip over to Azure Data Studio, and I'm going to connect to that database. And hopefully, that one is 1620. And I think this is remembering the short password, so that should be it. Right, so there, I'm connecting to it. It exists. I can interact with it. I can do whatever I want with it. There it is. And I can do them over. I could have many of these running. Another interesting thing to see in terms of resource usage is here on the stats, it's not really using that much memory. And it's using the memory inside of the Docker engine. So my Docker engine, I think I set it up for 2 gigs. I can't remember, right? But it's only megs. Right? Yeah. So it's only using memory. It's not using my regular system memory. It's just using stuff that's been set aside within the scope of Docker Engine. So if I was running a lot of these, I'm not going to be bringing, obviously I might hit a wall with how much memory I assigned to the Docker Engine, right? But it's not going to interfere with what's going on with the rest of my computer. That's the whole business of it being isolated. So that's the first, holy smokes for me. And And another thing, I'm not going to demo this part, but we also have the concept of volumes in Docker. So it's a separate, it's kind of like a container, a completely separate container. So the engine is running in my container. Right now, I didn't create a volume, define a volume for that container. So if I created a database and put data in it, et cetera, that's all in the same container. And if I shut the container down, it's all gone, right? I can stop the container, that's a different state, and start it back up again, and everything will still be there. But if I take the container down completely, all that's gone. But if you set up a volume, then the database itself, right, that's different than the server, the database itself and all its data will be in the volume. And the volume will stick around until you kill the volume. So I could create it with one container, then I could use it with another container, get rid of the first container, but the volume's still there, so the second container's still doing what it needs to. I could have another container, I could get rid of all the containers, I could just keep doing that, and the volume's still there. So my databases and the data that I've created are all there. Does that make sense? So I'm not doing that here in my demo. Everything will just be in the same container with SQL Server engine, so whatever I create and get rid of, which for testing scenarios is probably generally perfectly fine. It all depends, right? Depends on what your goals are. So the demo that I'm using is a pretty simple one. I originally did this talk at an Agile conference, so I decided my domain was going to be my gal pals in Agile. So I have my base model just has an ID, a string for a name. We have categories of their focus of expertise within Agile. So the Agilista has a reference to primary focus and their Twitter handle. So that's pretty simple. I have I'm so glad it's all .NET people. So I have a .NET Web API, and I've updated everything to .NET 6 and EF Core 6. So that's what's on GitHub. So I have a basic controller that just gets all those Agilista objects along with their reference data, along with those navigation properties to the categories. So it's just pretty simple. And I also have another little controller, just a values controller, that just deals with strings, has nothing to do with the database. And I like having it in there, not for production, but when I'm developing and testing, because so often maybe I'll do something wrong in the more complicated controller, and or with a database, or something's not working. And I like to just be able to verify that the app itself is working. So if I can, hit the values and those come back. So I've got those in there, especially when you're dealing with containers, because it's in this little box. So it's really nice, to see what's failing here. Okay, well at least the application, you can tell the application's running. And I also have some unit tests. And the unit tests aren't integration tests. They're just basic unit tests to make sure IDs get generated, things like that. And I have some integration tests that hit the actual controller methods. And of course, the controller methods are hitting the database. So that's kind of a full integration, maybe interaction. So here's the project, well, the solution, really. So I've got 3 different folders in here, and this is the Web API project. Now, remember I said that I'm using a mix of EF Core migrations and this other tool that I'm using. So what I'm doing is I'm using EF Core EF Core migrations to generate SQL for me, right? So I'm not running update, like database update. I'm not doing that at all. So I just used it for that, and then I'm grabbing that SQL script and then letting something else migrate it in another container. That's that flyaway that I mentioned before. So there's really nothing interesting about the controllers. It's just, I've got one that just returns all of the Agilistas, including the related data, the primary interest or primary focus, and then there's another one where you can pass in pass in a value and just get one. What else? Nothing interesting there. Okay, so before I show you more code, let me give you an idea of this integration between containers. So I have multiple containers here, right? I've got my database my database and the server, SQL Server, they're going to be in one container. My web API is going to be in another container. And I'm going to have a third container. So for those of you who use Docker, you're probably familiar with Docker Compose, which allows you to orchestrate multiple containers. Okay, so we have to a whole bunch of stuff needs to happen, right? When I run this app, I need a new or maybe existing version of my database container. In my case, I want to new it up every single time, new container every time. And I need it to compile and build an image of my web API and then run a container based on that, right? And then the third thing is I need my migration. I need my database to get created. So there's a whole bunch of options we have, for example, EF core migrations. But what I'm going to be using, and I'm dealing with small databases, what I'm going to be using is this FlyawayDB. And this is a migration tool for databases. It works with lots and lots of databases. It's actually a Java app, so like it uses a Java connection string. That was new to me. I've never used one of those before to get to the SQL database. But what it does is you give it a connection string to your database, you feed it your SQL script files, and it applies them. And it's idempotent, so it knows what, in the same way EF core migrations keeps a track of which migrations have been run. So it keeps track of which script files have been run. So that's what I'm using in the third container. And the way that works is, actually, I've got a visualization here. So I start by spinning up the SQL Server container, right? Once that's running and ready, right, it's gone through all the script. Once it's running and ready, I spin up the FlyawayDB container and tell Flyway, okay, do your thing, right? So I'm feeding the scripts to Flyway. And so do your thing means, look at the database that I've given you a connection string to and run these scripts. Once it's done, that Flyway container goes away. I don't need it anymore. I'm not wasting resources. And then the last thing that happens is I spin up the API. The API also has an awareness of the connection, and then I can use the API against the database, right? So that's the process. Never enough time, no matter how well I plan it. So here's the Flyway folder, and in here are the SQL scripts that I created. Now, my EF core migrations actually does a little more than what you see. If you generate the SQL script, let it generate a SQL script. It doesn't show you create the database and create your user accounts and things like that. So my first, it's up here. So my first script down here is what I got from EF core migrations, this SQL that it created. But up here is what I created myself, right? Because I need to, I'm going to have my own login, right? Not that SA default login that I fed to Docker run command, but I want to create my own login. And then I give login its permissions, what roles it has, et cetera. And then I create the database. Right? So that's what's going on in that first script. And then I have another script. Again, I let EF core create this for me. I was using the seed, the method you can use, methods you can use in the DB context to create seed data. So I let it generate the SQL for that, and then I stuffed the SQL into another one of these script files. But I did also have to explicitly add this, right? Because otherwise, EF core usually does that part for you. There's also naming semantics for the files, so Flyway knows what order to run them in. So, I don't need to get into that. But so what happens then is there will be a flyway container in the mix here in this orchestration. So here is, especially for those of you who've never used Docker or Docker Compose, just know that this exists. So the Compose file to do this orchestration I've set up 3 different services. So this first one is the one that has the instructions to build up the image for the web API and run it. The second one is the one that knows how to run the container. This is, instead of using the command line, right, I've got it here. So it's the same information that you saw in the command line to create the database server. And then the last one is to use the flyway image, create a container. It creates a volume for those SQL script files, and it knows to copy them in there, right? So that's part of how the container works. So I don't have, oh wait, nope. It knows how because I have a Docker file here, right? And it copies everything from my flyway folder into there. So it knows what it's going to be doing with the SQL scripts. The entry point is saying run the flyway migrate command. And then in addition, I'm feeding the connection information to the command. So to get to the server, right? So there's SA, there's the same password I defined before. And here's over here is the JDBC connection string, just a little different. But the most important thing here is remember how SQL Server has to run its own script before the database server is truly ready. So Flyway needs to make sure it's ready before it can do that. So I just have this also parameter or attribute connect retries 20. So it'll just try to connect. And as soon as it's able to connect, then it goes and does its thing. It runs the migration. There's a couple other interesting things here in the migration service. Notice I've got depends on the service called DB, right? So it won't even try to start until that service exists, right? It doesn't know how to wait until SQL Server is finished running its own internal script, right? That's what the connect retries. But it won't even start to do anything until that container exists. And the API depends on the migration service, right? So it won't even try to do anything until the migration service has actually, the migration service, remember, the way I've set it up, it spins up and then goes away, right? And then when it goes away, then the API is like, okay, I'm ready. I'm going to be able to do what I need to do. So there's one other interesting thing going on here. I'm using environment variables, right? But not from my computer, right? Because that you can't share. And also keep in mind, this is dev, test, CI/CD. This is not my production server, right, that I'm going to be putting into GitHub and sharing with a team, right? It doesn't matter. It's just a throwaway database on a local machine or on your CI/CD server. So Docker Compose, by default, will look for a file called .env. You can also tell it to specifically look for an explicitly named file, .env. But I'm just using the default. And env, I've created this value here for dbcon, and there's my connection string. So now this connection string will get shared throughout the different containers. So I don't have to specify it every time. It's a little different for the JDBC connection. I had to explicitly put that information in there. So that was a big thing for me to learn and understand how to do that. So now what I'm going to do finally is I've got my Docker Compose file, and I'm in Visual Studio Code, and it has Docker extension. So I've got that installed. And I'm just going to go down, just in case you can't see it, one of the menu items is Compose Up. And so that's a default Docker Compose command that is all I need So I'm just going to let that run. And now, while that's happening, so it's doing a whole lot of stuff, what I want to do is go over to Docker desktop and see what's going on. So notice none of the new containers are up yet. It's still building the web API image. That was the biggest work. Now, oh, it's ready. So this is the collection of containers that are all orchestrated together. So you can see all three of them are running. The DB is running. The Flyway migration is running up there. If I had opened it earlier, it would have just sat there for a moment, waiting. But it made its connection. Don't worry about this warning. Everything happened. It found two migrations and validated them. In other words, it understood how I use the naming convention, and I don't know if it really means it's validating that it's good SQL or not. I should screw up the SQL and see what happens there someday. And then it ran them, right? So you can see, well, maybe you can't. Here, this was the first one, it ran that one, and this was my second one, it ran that one. If I were to go into Azure Data Studio, I could connect to that database and we can look at it, but why bother with that when we've got our API is already running now. So, hey, localhost, and I exposed my API. I don't think I showed you that. So much to look at. I exposed the API on port 5114. So I'm just going to go to localhost 5114 and then into API Agilistas just to hit the get command. And there it is. There's all the data coming that I seeded into the database container, right? Pretty cool. And I'm like, do I have time to do all of these little fun things? So I am going to go ahead and connect to it because I want to show you something else. So I connected to it before, so I saved the connection. That's great. Databases, there's my database. There's my Agilistas table. Right, so I can work with it just like it's installed directly on my MacBook. Right, MacBook. That was the first place I tested it, right? Like SQL Server for Linux, I'm going to pull up my MacBook and try that. So I put this into edit mode, so I'm going to rename that to my dog. I already miss her. I've only been gone a day. Now I'm going to go back to my API and refresh it. Right, there it is, right? So I'm interacting with it all over the place. So next is testing, right? That was dev. What about test? So I have a third project in there, which is, sorry for all the scrolling here. Here's some model tests, right? I've got a couple of unit tests. I explained before, I have some unit tests that just make sure GUIDs are getting correctly, IDs are getting generated correctly, et cetera. And I've got a couple of integration tests. Oh yeah, I showed you those because I explained that the integration test hits the controller and the controller is dependent on the database. So this works only a little differently. I still have this orchestration. However, inside of my compose file, see I have multiple compose files. This is like a default one, but this is another YAML file. And I can't collapse these quickly. Instead of the API, I have a service for unit tests. And the unit tests work on my model tests project, okay? And what else do I want to say about that before I show it to you? Oh, we're back here. Okay, so same, I spin up the SQL Server engine. I spin up Flyway. I apply the scripts. That goes away. And then my test container spins up, runs its test, but here's what's different. I'm not going to leave the test container up and running because once the tests are done, I'm done, right? So I make the container go away. And I should probably make the database container go away too. So running that, I'm going to do this a little differently. First, I like just for testing, I just want to clean things up a little bit. So I'm taking down the containers, the set of containers that I created a bit ago. Now, remember I mentioned the detach mode. Detach mode because I want the, I need the tests to complete and be done and it go away. So I don't want detached mode here. It took me 3 days to figure out why my tests weren't working when I was first learning how to do this. And nobody could help me. I'm a Docker captain. The Docker captains couldn't help me. Docker engineers couldn't help me. Google couldn't help me. And I just tried a million different things. I had no idea what I was doing, but I finally realized, I finally figured that out like somehow and then tested it and was like, oh, okay. And then talked to people and realized, you know what, like backed up. Like I had now I had the data of what was different when it worked, and then somebody explained to me a little better why that worked. Anyway, so I can't just right click because that default Docker Compose message, Docker Compose command will put it into detached mode. I don't want that to happen. So this one I'm going to run manually. Oh, there it is. So there's Docker Compose. And because I'm using an explicitly named file instead of just Docker Compose.yml, which is what it will look for by default, I'm using the parameter -f for file name, and I'm saying the file name. I'm also saying up and also saying build, like you always have to, but I don't have the -d in there for detached mode. So that's running, and I think it's more fun to watch in here. So there's the set of containers. They've been created. I think it's probably working on building up the image for the unit tests right now. Oh! Is this what I get for testing my demos like 40 times? Port is already, oh, the port, it failed because in my Docker Compose file, I'm specifying port 1620 for the test, and I used 1620 when I manually spun up the database to show you that the first time, and it's still there. So I don't know if you saw error response daemon, blah, 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 DB1, right? So I knew it was a database container. 1620 is already allocated. So I'm just going to go over here. I did not do that on purpose because, you know, I didn't really have extra time for that. So let's try it again. Let's see if it'll work without me having to take all that stuff back down that got partially spun up. Okay, now the database is running at 1620. The migrations are running. There they go. Doing the same thing. The unit tests are running. I'm going to go back to Visual Studio Code. It's reporting what it's finding. And 0 failed, and all 8 of my tests passed. I don't care anything else, right? All right. I should have started at 10. So everything's working great. Everybody's happy. Now the business comes and says, oh, these Agilistas, they're so smart. Just limiting them to one primary focus in our database isn't enough. We need another primary focus. So they're like, okay, we need to change the model. We need to change the controller so that it exposes this extra information that we're going to have in. The database schema is going to change, and the tests. We want to make sure that the tests account also are looking to make sure that we're getting that correct data back as well. So if we weren't hitting the database, that would be fine. But we're hitting the database, and right, normally that would not be fine because we'd have to go through all this business of sharing sharing the new SQL scripts. So I'm using the containers. Do you mind an extra couple of minutes? Like just a couple of minutes, not 10 minutes? So I have another branch here, and I'm telling you that because this is on GitHub. And I've already done all of that work. Okay, I've most importantly, not only have I changed my code, but I've got a new SQL script in there. That's the only change really with respect to the database. I've added a new SQL script file into the Flyways SQL folder, right? So, and you know, I've changed my code, all those other things, I've made all those changes. But all I've done with respect to the database is just add this new script. And then I can do the same thing I did before. Oh, I got to take everything down first. Let's just compose down. I just want to make sure everything's clean, just because you never know. OK, so I'm going to compose up. This is the API. So it's just doing exactly what it did before, except when it comes to Flyway, it's still working at building those containers. There it is. There it is. When it comes to Flyway, it just has one more script to run in the migration. Flyway's still waiting. There it goes. See, validated 3 migrations, right? So, I mean, it's no big deal, right? I just added a new script, no big deal. And when I go, I'm assuming it's all ready now. When I go back here, it's going to be a whole new version of the database, reseeded data. So I don't have Josie anymore. But there's the secondary focus information. And then I do the same. I won't waste time showing you. But for the test, all I did with the test was I added a new test that also verified that, you know, like one of these pieces of data was also coming back in secondary focus. And then I compose up, right? I run it, and it works. And then it says 9 tests passed, because it all works. And all I really had to do, once I had this set up, all I had to do was add another SQL script. And it's nothing. It's amazing to me, even though I've seen this working for years. So there's the summary screen. There's the resources slide, so you have access to that. All the code and even this PowerPoint presentation are all in my GitHub repository I created. Oh, I think it's still private, because I just recreated it. So I just have to make it public, but it's just my GitHub repository Docker database. So pretty cool stuff, right? And for those of you who haven't used Docker before, were you able to kind of follow along? Docker's really hard to get your head around. I'll just tell you one thing about Docker. It is not a virtual machine. That is the most important thing to understand, the hardest thing to wrap your head around. Thank you so much. Thanks for the couple of extra minutes.
Thank you, Julie.